All right, yesterday we were looking at radian values, how we have this alternative or other way to measure an angle, and a radian isn't necessarily measuring the angle itself. A radian is representing how far you'd have to walk around the circumference of that unit circle. But we realized yesterday how that distance you would walk around the circumference is directly related to the angle formed by the center of that circle. So they are related together. It's just a different way for us to measure or represent an angle. So today's going to be fairly short. We're going to go ahead and practice getting used to working with these radians. We talked about yesterday how we can convert them to degrees if that helps us work with them a little bit easier. And then we're going to take a look at a free response question today as well. So I don't think it's going to take too long. We're going to have plenty of time to maybe go over some homework questions or practice today. And then tomorrow I'll give you kind of a review worksheet to help prepare you for the quiz on Thursday. Okay? So let's take a look. On page 377, we are given an angle. Notice how we have that Greek letter theta, and some of the angles are in degrees, other ones are in radians. What we're going to try to do is figure out if we were to draw these angles using a coordinate system, like an x and a y axis, which quadrant would the angle terminate in, aka end, and then we're going to try to figure out the measure of theta prime. You see that little apostrophe in there? That just means prime, some other angle. We're going to let theta prime represent the reference angle. Okay, how far we are, or the angle measurement to the closest x-axis. All right, let's start with the first one. So we'll go ahead and draw in our coordinate system. We will label the initial side, okay, that positive x-axis. And we're going to draw our arrow of rotation, 275 degrees.
Good morning.
Good morning. Anything for the office? I think we're good.
Okay.
Thank you. All right, so let's go ahead and count 275 degrees. If we go through one quadrant, that's 90 degrees. If we go through another quadrant, that would give us a total of 180. Notice how that's half of a circle, so that should make sense. If we go another 90, we're at 270, but we're not quite at 275 just yet, so we have to go a little bit more into that next quadrant. So as soon as that arrow of rotation ends, we'll draw in the terminal side. Now that we have a visual of it, can we determine which quadrant this angle terminated or ended in? Do you remember the order of your quadrants? Which quadrant did we draw in this terminal side in? Yeah. It is quadrant 4. All right, so for your quadrants, they go counterclockwise, just like the way we draw that reference, or not reference, that arrow of rotation. So 1, 2, 3, 4. This would land in quadrant 4. Let's also try to figure out theta prime. Okay, that is the reference angle, the angle measured to the closest x-axis. So in our drawing, the reference angle would be this angle right here. Can we try to figure out what that measurement is? Remember, it should be less than 90 degrees. It's an acute angle. Let's think about it. We said we had to go 5 degrees into that fourth quadrant. So it looks like the reference angle is that remaining angle measurement. Yeah? It'd be 85 degrees. Is that what you're going to say too, Ashton? Perfect. Okay. So our reference angle is 85 degrees. That is an acute angle. We're good to go. All right, let's try the next one. Negative 597. Okay, we'll draw our coordinate. We'll label the initial side. And then negative measurement, so our arrow of rotation needs to go backwards. We're definitely going to do a full circle because that would get us to 360. If we go another 90, that would be 450. Another 90 would be 540. And to get to 579, looks like we have to do 39 more degrees. So we're not quite getting out of that quadrant just yet. So we'll draw in the terminal side, and there's our angle. Which quadrant did this angle end in? Yeah?
The second.
Quadrant 2, perfect. And let's see if we can figure out the reference angle. The measurement from the terminal side to the closest x-axis. So in our drawing, that would be this angle right here. Can we think about what that angle measurement is? Yeah, 39 degrees. Yep, that was how much extra we had to go into that second quadrant in order to create that angle. So that would be our reference angle in this particular case. 39 degrees. Good. Can you guys see that green marker? Yeah. My pens are slowly dying on me and I need to buy more, but these are the only ones I have so far. Okay. All right, let's go ahead and check out some radians. So the first two might not have been as difficult because we're working with degrees. We're very familiar with those. If I asked you to draw an angle of 3 pi over 6 radians, would you be able to do that as easily as you did the previous two? Probably not, okay, because we're still learning or trying to get accustomed to radians. So in the meantime, let's perhaps try to convert this to a degree measurement. That way we can draw the angles like the first two we did. So from yesterday, can we think about what we have to multiply this radian by in order to convert it to a degree? Yeah. 180 over pi. All right, so on your calculator, we'll go ahead and multiply the numbers across the top and across the bottom. We'll leave the pi's in there. Hopefully you realize the pi's would cancel out, so there's actually no need to multiply them through. What's our congruent degree measurement? Can we get it? Yeah, 390. All right, so instead of drawing an angle that's 13 pi over 6 radians, we could simply draw an angle that's 390 degrees. They're going to be the same exact angle. So let's go ahead and give it a shot. There's our coordinate. We'll draw the initial side. Arrow of rotation, we're doing more than a circle, and it's positive. So a full circle is 360. We would have to go an extra 30 in order to get to 390. So we'll draw in the terminal side. Which quadrant do we land in? Good, Marie? The first one? All right. And let's see if we can figure out that reference angle. Okay, so measurement to the closest x-axis, that would be this angle right here. Yep, 30 degrees, yep. In this example, that's how far we had to go into the next quadrant to complete our angle, so it happens to be 30. All right. I made a mistake though. Okay, we're not going to write 30 there because we started with a radian. That means I want to end with a radian. So we have to convert it, do another conversion back. If our reference angle is 30 degrees, can we convert that back to a radian? What would we have to multiply 30 degrees by to convert it to a radian? Yeah? Pi over 180. All right, so let's go ahead and convert it back. keep the pi in there. We're just going to go ahead and simplify the numbered values to create a fraction. So if we simplify 30 over 180, what would we get? Yeah? 1/6. Okay, so we have 1 pi up top and then a denominator of 6 on the bottom. So we found the reference angle to be 30 degrees, but again, if you start with a radian, we're going to end with a radian, just making sure we're consistent. We might have to convert it back. All right, let's try the next one. Maybe we'll convert this one as well. Can we figure out our congruent degree measurement? Yeah? Negative 108. All right, so let's draw that angle. All right, negative, we got to draw it backwards. If we go one quadrant, that's 90 degrees. Looks like we'd have to go 18 more into the next quadrant to get that 108. So we will draw in the terminal side. There's our negative 108 angle. So it looks like the quadrant is quadrant 3. And let's see if we can figure out theta prime, our reference angle. Yeah? All right, so this reference angle to the closest x-axis is 72 degrees, but we started with a radian, so we're going to convert it back to a radian. Let's take that 72 degrees and multiply by pi over 180. We're going to keep the pi. We're just going to simplify the numbered values. So if we were to simplify 72 over 180, yeah? 2/5. 2 pi over 5. Are we doing okay? I'm hoping radians, we're not getting so scared of them because I know they are a little bit different. We can easily convert them so that we can work with them a little bit easier. Okay, kind of less stressful. Let's go ahead and take a look at a free response type question. All right. During a hike, Jeff and John started at their campsite, which was point A, and they headed in a direction that is 30 degrees west of south to a waterfall located at point B. So they very nicely labeled that triangle angle for us, which is a 6-mile hike. They then hike to an old Indian burial ground located at point C before returning to their campsite, which is 8 miles from that burial ground. So we have this nice visual triangle to help us out. Using the given information, how many square miles did Jeff and John hike that day? All right, so we know they're only hiking along these linear paths, aka the line. But notice how if they were to completely enclose this geometric triangle shape, they covered some area. Okay, square miles. We have that square unit. So can we calculate perhaps the area that they covered? Bless you. How can we calculate the area of a triangle? We know it's 1/2 base times height, but that's just for right triangles where the base and the height are easily found. We don't know for sure if this is a right triangle or not. Yeah? You could. I mean, that's what we're going to do later on in parts B and C. Okay, but apparently there should be enough information given to us here that we could figure out that area. What do you think, Tori?
Is it 1/2 times side length times the side of 30?
The sine of 30, yep. So we got to know that side, angle, side relationship. Notice how we have that here. We know two sides and the angle they form. So we're going to take 1/2, just like 1/2 base times height, times the two side lengths we know, and then times the sine of the angle they form, which would be that 30 degrees. So using your calculator, making sure you're in degree mode, because this is an angle measured in degrees, let's go ahead and calculate the total square miles area that they covered. Anybody get it? Yeah. 12, there we go. 12, and then we have some units. We'll say miles squared. Can we get 12? Looks good. All right, let's check out B. How far did the two young men hike in all? Okay, so they're only walking along the linear paths. What do we need to figure out in order to calculate how far they traveled? Yeah. The perimeter. Okay, so we're going to have to add up all those sides. We know one side is 6, one side is 8, but we don't know this third side. Maybe we'll label it side A because it's opposite angle A. So in order to figure out the perimeter, we got to figure out the value of this third side. And they're conveniently giving us a clue to use the law of cosines to help us out. I hope that makes sense because there's no way we could use the law of sines. We do not know an angle and its opposite side in that picture. So that means law of cosines would be our only other option. So law of cosines is kind of that long equation with the squareds going on in it. But let's see if we can try to figure it out. If we want to try to figure out a squared, we're going to, or a, according to the law of cosines, we're going to square that length a, and that should equal some relationship between the other sides and angle A. Without looking back, can we try to use the 6, the 8, and the angle 30 with the rest of the law of cosines? What do you think, Tori? Okay, or other way around. Totally fine. Yep.
Plus 2 times 8 times 6.
Close. It's minus, but you're on the right track. Minus 2 times 8 times 6, or 2 times 6 times 8. Either way. Yep.
And then multiply by
Cosine of 30. Perfect. All right, law of cosines. So we're using that cosine trig function. All right, so you're going to start with some side length, and then according to the law of cosines, you're going to use the other two side lengths and the angle opposite the side you're trying to figure out. So what's nice about this is if you look on the right-hand side, we have numbers filled in for absolutely everything. That means we can utilize our calculator to simplify that right-hand side to just a number. So go ahead and type all of that in and see what we get. Let's see, I got 16.862 right? But we'd have to square root that to get our length of A. So I think it's 4.106. Would you guys agree? All right. Did we answer the question? Is that how far they hiked in all? No, we got to calculate the perimeter. Okay, we got to add up all those sides. So 6 plus 8 plus this 4.106 that we calculated. Looks like 18.106, and our units are miles. That's one heck of a hike. We doing okay so far? All right, let's check out the last one. Upon leaving the waterfall, so I think the waterfall was at angle B, how many degrees did the two turn from their original path to get to the burial ground, which was at point C? So I guess we're trying to figure out angle B, because this is where the waterfall was, and this was the Indian burial ground. Okay. And they want us to use the law of sines in this case to help us figure out our answer. Okay, so let me kind of scoot this up a little bit. In order to use the law of sines, we must know an angle and its opposite side. Do we have that information available to us? Yes. Which ones do we know, Marie? You're shaking your head?
We know angle A and the opposite side, which is 8.
There we go. So we can use sine of 30, that angle A, and we just calculated its opposite side, which was 4.106. So we're going to use that relationship to help us figure out angle B. What would the fraction look like for angle B according to this law of sines? Can we set it up? If we're looking at angle B, go ahead, Tori. Sine of theta or sine of B, good, over its opposite side, which should be 8. Perfect. All right, so calculator time. We'll go ahead and type in sine of 30 over 4.106. Let's see. We get 0.122, maybe you want to round it. Let's go ahead and multiply the 8 over. We get 0.976. And how are we going to move the sine over? Yeah? Sine to the negative first. All right, so we got to do sine inverse and then type in 0.976. And looks like we get 77.4 degrees. How are we doing? Pretty good? So this particular free response didn't really involve radians too much. I guess it was a good kind of review of law of cosines and sines and area that we were talking about in the previous section, but still a good practice nonetheless. Okay? So that's it for this section. The remainder of the period you can use to work on some homework problems. Tomorrow I'll give you a practice worksheet to help you review for the quiz on Thursday, and tomorrow I'll let you know who your partners are. Okay?